Hello everyone, in this video we are going to do a lot of examples. First we'll draw the Lewis dot structures and then we'll tell whether the molecule is polar or non-polar and what kind of bonds the molecule has. Okay, so let's start. Our first example is selenium difluoride. So you should know the names of these molecules, right? Selenium, there are two fluorines, so it's difluoride. We do not start the name with mono, so it's just selenium difluoride. Okay, so let's first count the total number of valence electrons. So it has 20 valence electrons. So whenever we have to tell whether the molecule is polar or non-polar, the first step is you draw the Lewis dot structure of the molecule, right? So let's draw the Lewis dot structure of selenium difluoride. So selenium, the single atom goes in the center, and then I'm going to put the two fluorines next to it, right? Join all the outside atoms to the central atom and then complete each atom's octet starting from the outside atoms because they are more electronegative, right? So we already used 2, 4, then 6, 8, 10, 12, 14, 16, right? So we have used 16, then 17, 18, 19, 20, right? Selenium completes its octet, fluorine completes its octet, and we are done with all the valence electrons. So now this molecule has two lone pairs. Next thing, once we have drawn the structure of the molecule, we write down its AXE formula, right? Now look at the molecule. So we have one central atom, so A, and then we have two fluorines, two bonds, two covalent bonds. So X is 2, so X2. Now we have to look how many lone pairs are present on the central atom. Since there are two lone pairs on the central atom, so E is 2, right? Now the steric number for this molecule is X plus E, which is 4. So 2 plus 2 is 4, right? So the ideal shape would be tetrahedral. But since the two bond pairs are replaced by two lone pairs, right? Now in steric number 4, AX2E2 is bent, right? So the molecular geometry of this molecule or the shape of this molecule is bent. And always remember, bent is always unsymmetrical, right? Because the lone pairs destroy the symmetry of the molecule, they push the bond pairs closer. So the angle between the two bonded pairs is less than 109.5. So this is a polar shape, right? So bent is the molecular geometry and the molecule is polar, right? Next we have to tell what kind of hybridization is present in this molecule, right? So to tell the hybridization, we always have to first see what kind of orbitals are joining. Hybridization is mixing of orbitals. Like, you create a poodle, you have a poodle or any other dog breed, and then you do the hybridization, you come up with a new breed, right? So since there's only one s orbital, and then there are three different orientations of the p orbitals, three different type of p orbitals, and then we have 5 different d orbitals, 5 different orientation of the d orbitals, right? So when our steric number is, so we have to know the steric number. So if steric number is 4, it means we are mixing 4 different orbitals. So we always start with s. So 1, 2, 3 and 4, right? So the hybridization would be sp3. We are mixing 3 p orbitals with one s orbital because we have steric number 4. It means there are 4 things around the central atom. So 4 orbitals mix together to make 4 different hybrid orbitals that have the same energy. They are called 4 different sp3 hybrid orbitals. They have same energy, right? So the hybridization would be sp3 because the steric number is 4, 1s and 3p. So that is a total of 4 orbitals, right? So the hybridization would be sp3. Okay. Next we are going to do XeO4. Now XeO4 has 32 valence electrons. You can count. Xenon has 8 and each of the oxygen has 6, right? So total of 32 valence electrons. And if you draw the structure of XeO4, Xe goes in the center. The 4 oxygens go, I already know the shape, so I'm gonna draw them not in the cross form but like that, right? And then you complete the octet of each oxygen, right? And you will see we have used up all the valence electrons, right? So you can see there is no lone pair on Xe. So the formula, AXE formula of this compound or this molecule would be just AX4, right? So AX4, 4 things around the central atom and no lone pair is always symmetrical. So this AX4 is tetrahedral and the bond angles would be 109.5, and this shape is non-polar because all the X atoms are same. They are all oxygens, right? So this is tetrahedral and the molecule is symmetrical because the X atoms is same, and hence this molecule is non-polar. About the hybridization, the steric number of this molecule is 4. So again, steric number 4 means 1s and 3p orbitals mixed together. So the hybridization is sp3. Okay. Let's do another one, CO2. It has 16 valence electrons, carbon 4 and each oxygen has 6. So 12 plus 4 is 16. Carbon goes in the center, the 2 oxygens on the 2 sides, arrange those symmetrically, and then if you draw the Lewis dot structure, right, you will see there is a double bond between the carbon and oxygen, right, and then each of the oxygen has 2 lone pairs. So this is the structure of carbon dioxide. Now here is the thing, the AXE formula should just be AX2, right? Now since C and O bond is polar, right, each of the CO bond is polar, so this is polar. Now if I draw the polarity of this bond, it's gonna be towards oxygen because oxygen is always more polar or more electronegative than carbon, right? So this is the direction of the polarity of this bond. And look at the other CO bond. The direction of the polarity is like that, right? So the individual dipole, since oxygen atom is same on both sides, right, the magnitude of the polarity is same on both sides. So that is denoted by the length of the arrow. The length of the arrow is same, right? But the direction of the polarity is opposite. So the individual dipoles, they cancel out. So this cancels with this one, right? So, and since there is no lone pair, it can't be bent, right? So AX2 is always linear and hence it is non-polar because it's symmetrical. So this is a non-polar molecule. If you draw the structure of carbon monoxide, there will be a triple bond, then the bond will be polar, right? So carbon monoxide is polar, whereas carbon dioxide is non-polar because it's symmetrical. Now let's talk about this the steric number. The steric number of AX2 is just 2, right? So what is the hybridization? The hybridization would be sp. Okay. So one S and one P mixed together to make the hybridization sp. Okay. Let's do another example. So we have PCl5. PCl5 is 40 valence electrons. So 5 things around the central atom. I'm gonna make 3 things around a triangle in a triangle. So 3 chlorines like that in the shape of a triangle, 1 on top and 1 on the bottom, right? So if you count the total valence electrons, right, phosphorus already may have 10, and then if you give each chlorine 6 more, you're gonna be done with all the valence electrons. So there is no lone pair on the central atom. AXC formula is AX5, which is trigonal. The shape is trigonal bipyramidal. Trigonal bipyramid with no lone pair, right? So that means it is symmetrical. So trigonal bipyramidal is symmetrical because all the X atoms are same and hence it's non-polar. All the X atoms are same, so this is a non-polar molecule, right? And what would be the hybridization? Since we have steric number 5, so how many S and P mixed together? So this time we have 1, 2, 3, 4 and 5, right? So sp3d. When steric number is 5, the geometry would be 1s, 3p and 1d. So total of 5 orbitals, right? So that would be sp3d. Okay. So let's write that down. The hybridization is sp3d. Okay. Let's do another example. SF4 with 34 valence electrons. So SF4 has this structure. So if you draw the Lewis dot structure, sulfur goes in the center, and then I'm gonna arrange the 4 fluorines in a square shape around the central atom, right? And then 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 29, 30, 32, right? So we still have 2 more to go. So those 2 are as a lone pair on the central atom, right? So if you draw SF4, this is the Lewis dot structure of SF4. Now SF4 has 4 and 5 things. So the AXE formula is AX4E, right? Steric number is 5. So ideally it should be ideally this should be SF4 should be AX4E, that should be seesaw shaped, right? And then the molecule is polar because this is unsymmetrical, right? So this is seesaw and this is polar. The geometry for steric number 5 is sp3 and then 1d, right? 3 plus 1 4 plus 1 5, right? So sp3d is the geometry of this, okay, steric number 5. Okay, now let's do another one, XeF2. So there are 22 valence electrons, you can count. So if I draw XeF2, So this is how it looks like. XeF2 has how many lone pairs? So 2, 4, 6, 8, 10, 12, 14, 16, right? So 6 plus 6, 12, 13, 14, 15, 16, then 17, 18, 19, 20, 21, 22. There are 3 lone pairs on xenon. Okay. So the AXE formula becomes AX2E3 and the steric number here is 5. Steric number 5 is trigonal bipyramidal. So all the 3 bond pairs in the plane of the triangle are gone, right? So trigonal bipyramidal with 3 lone pairs, a distortion is linear. You can see that this is a linear molecule. So this shape is linear. And then again the hybridization is sp3d. Okay. Next we have NCl3. NCl3 has 26 valence electrons, and then if you draw the structure, so we have 1 nitrogen here, 1 Cl here, 1 Cl here, right? And then you join all of these, give them 6 electrons each. So chlorine completes its octet. So we have used 6 times 3, 18, 19, 20, 21, 22, 23, 24, and there's 1 lone pair on nitrogen, right? So this lone pair is going to push these bond pairs, right, away from it. So the molecule is not trigonal planar, right? So whenever there's a lone pair on the central atom, it kills the symmetry. So the AXE formula is AX3E, right, which is pyramidal, trigonal pyramidal, right? So AX3E is trigonal pyramidal. So this is unsymmetrical and hence polar, right? So this shape is polar because this is unsymmetrical, and the steric number is 4, right? So the hybridization would be sp3. Okay, steric number 4 has hybridization sp3. Okay, now let's do SiO2. So SiO2 has 16 valence electrons. Silicon goes in the center, and then draw the oxygen symmetrically, and then you will see there's a double bond between Si on both sides, right? So there are 2 lone pairs on each oxygen, and this is the structure of silicon dioxide, but there is a lone pair on the central atom. So now this lone pair is going to push these bond pairs away. So this kind of looks like this. Now this lone pair that is on silicon, right, that makes the molecule unsymmetrical, unlike CO2. Remember, CO2, there was no lone pair on the central atom. So the individual dipoles, they cancel out, right? So if you draw the polarity of SiO2, because of the lone pair, the molecule is not symmetrical, right? So the overall dipole moment is in this direction, towards the 2 oxygens, right? So this molecule is, the AXE formula is AX2E, right? Steric number 3, and then AX2E is bent, and this is polar. Okay, trigonal planar, that is the hybridization. So this is polar and the shape is bent. The hybridization for this molecule is, since the steric number is 3, so that is going to be sp2. Okay, So 2p and 1s, they mix together. So 3 orbitals, 3 hybrid orbitals, they overlap to make this molecule, right? Next is BH3, 6 valence electrons. So B goes in center, the 3 hydrogens symmetrically in a triangle, and we are done with all the valence electrons. Always remember, hydrogen is happy with 2. Boron is one of the exceptions, right? Boron cannot have more than 6. So this is the structure. Now the AXE formula would be just AX3. Since all the X atoms hydrogen are same, this molecule is symmetrical and hence it is a non-polar molecule, right? Symmetrical, non-polar, and the hybridization, since the steric number is 3, so the hybridization would be sp2. When steric number is 3, the hybridization is sp2 hybridization. Okay, now let's do a few more and then we'll wrap up these examples. So hydrogen chloride, hydrogen monochloride has 8 valence electrons. Now since there are only 2 atoms, we can place them side by side, and this is the Lewis dot structure. Since there are only 2 atoms, when the 2 atoms are same, the molecule is always non-polar. Remember, all the diatomic molecules are always non-polar. But when there are 2 atoms that make a molecule and the 2 atoms are different, so there is a net direction of the dipole moment. You can see chlorine, being more electronegative, will pull on these shared electrons closer. So this end of the molecule will acquire a partial negative and this end of the molecule will be partially positive, right? So this molecule is linear, but since the 2 atoms are different, so this is unsymmetrical. There's a charge separation and hence the molecule is polar. Okay. Coming to the next example, CH3Cl. It has 14 valence electrons. Carbon goes in the center. The 3 hydrogens can be placed in a tetrahedral fashion like this, and then 1 chlorine here. Now carbon is slightly more polar, slightly more electronegative than hydrogen, right? And we can draw the direction of the polarities like this. So usually if you calculate the electronegativity difference, you will see carbon and hydrogen, they have very slight difference in the electronegativities. So carbon hydrogen bond is usually non-polar, but since carbon is little more electronegative, we may draw this polarity like that. Okay. Now there is a significant electronegativity difference between carbon and chlorine. So this polarity, this bond is polar, carbon chlorine bond is polar, and this is the direction. So if you check, the overall direction of the polarity is towards the chlorine, right? So since this molecule is unsymmetrical, always remember, so the steric number is AX4. It's still AX4 because there's no lone pair on the carbon atom, right? But since all the atoms are not same, X atom is not same, this molecule becomes unsymmetrical and hence this is a polar molecule. Okay. Next, let's talk about CH2O, right? So all the organic compounds, remember carbon has to make 4 bonds. So I am going to make the structure like this. Okay. Now if you see, this is how it looks like, right? And we are done with the 12 valence electrons. But carbon did not complete its octet. Carbon has only 2, 4, 6 electrons. It needs 2 more. So one of the lone pair on the oxygen is going to make a double bond with carbon, right? So the structure kind of looks like this. So oxygen has 2 lone pairs, and then carbon has completed its octet by making a double bond with the oxygen, right? So the AXE formula is still AX3. Now, whether the molecule is polar or non-polar. So this is what we have to see. Now, if we draw the individual dipoles, right? So this is the direction of polarity, right? Carbon is little more electronegative than hydrogen, and then oxygen is a lot more electronegative than carbon. So there is a net dipole moment in this direction towards oxygen, right? Even though the shape is square planar, trigonal planar. So this is trigonal planar. Trigonal planar shape, when all the atoms are not same, is unsymmetrical. So this is unsymmetrical, and hence this is a polar molecule. Okay. Next, let's do an ion. So we have nitrate ion, right? The total number of valence electrons would be 23 plus 1, 24 valence electrons. Nitrogen goes in the center. I'm going to put the 3 oxygens symmetrically around the nitrogen. Join with a single bond, right? And then put a charge, -1, on the outside, right? So if you see, nitrogen has 6, right? So we are going to make one double bond with one of the oxygen. It could be any oxygen. It's a resonance structure, right? And then other will have 6 valence, 6 electrons, right? So this is how nitrate looks like, right? The nitrate has a structure of, the AXE formula is AX3, right? Since all the oxygen atoms are same, all the X atoms are same, this is a symmetrical shape. Symmetrical because this is trigonal planar. All the X atoms same, so hence this is a non-polar molecule, right? And then the hybridization, since the steric number is 3, so hybridization is sp2. Okay. Next, I have drawn 2 organic compounds. So we have diethyl ethyl ether. So this is the formula, right? So we have oxygen. On one side of the oxygen we have a methyl group. CH3 is called a methyl group, and on the other side we have another methyl group. So it kind of looks like a symmetrical molecule, but if you draw the structure, you will see there are 2 lone pairs on the oxygen, and then the polarity of each bond is kind of like this, right? So since oxygen is more electronegative than carbon, so the bond polarity kind of is towards oxygen. Same with this bond, so it's towards that, right? So the overall molecule has polarity in this direction towards the oxygen atom. So this is a polar molecule. The shape is bent because if you look at oxygen, right, the lone pairs on the oxygen are going to push the bond pairs holding each carbon away, right? And then the shape around oxygen is bent. So this is a polar molecule. We had a similar problem in the card activity that we did in class, right? So whenever we have multiple central atoms, we have to look at the geometry around each central atom separately. So around oxygen, if you look at the oxygen, so there are 2 lone pairs and then 2 bond pairs that this oxygen is making, right? It's making a bond with 2 carbons, so 2 bond pairs, AX2, and there are 2 lone pairs on oxygen, so E2. So around oxygen, the steric number is 4, and then the shape would be bent around the oxygen. And if you look at the carbon atom, carbon is bonded to 4 different atoms. So 3 hydrogens and 1 oxygen, right? Like this, right? So carbon, around carbon, there's no lone pair on carbon, so the AXE formula is AX4. So it is tetrahedral around each carbon. Each carbon has a tetrahedral geometry, whereas the whole molecule is bent because oxygen has 2 lone pairs, right? So the overall polarity is, molecule is polar because of the lone pairs on the oxygen atom, right? So we have 2 different geometries here, and the AXE formula is around the oxygen is AX2E2, so that would be steric number 4. So this would be sp3 hybridization, and then this one would be sp3 hybridization as well. Okay, next we have methanol, right? So if you draw the structure of methanol, it kind of looks like this. So we have 3 hydrogens bonded to the carbon like this. Carbon always likes to make 4 bonds, right? And then there are 2 lone pairs on the oxygen, right? So around oxygen, the formula would be AX2E2. So just look at the oxygen. So this oxygen, then AX2E2, right? So this is bonded to 1 carbon and 1 hydrogen, and there are 2 lone pairs. So this shape is bent, right? So this is a polar molecule. And around the carbon, it is AX4, but since all the X atoms are not same, right, this molecule is polar. So around carbon as well as around the hydrogen, right? So the net direction of the polarity is going to be in this direction, okay, like this, right? So this is a polar molecule. Okay. The last example that I'm going to take is SO32 negative. It's an ion. It has 24 plus 2, 26 valence electrons, right? If you draw the structure, you might need to memorize this structure. There should be a double bond. Even if you don't draw a double bond here, right, then oxygen has 6 valence electrons, which is also good, right? But remember, I told you about the formal charges. This is something we did not cover in honors class, right? So for now, you can just memorize that there is a double bond between one of the oxygens in SO3 molecule, that is sulfite ion, right? The AXE formula would be AX3 because there are 3 bonded bond pairs and 1 lone pair on the central atom, right? So 1E. So the shape would be trigonal pyramidal. This is an unsymmetrical structure, and hence the molecule is polar. Okay, so this is a polar molecule. So that is all for this video. Hope that was helpful.